Hi everyone, we are going to get into Module 22 when we are doing hypothesis testing for a proportion. We're going to get into it. So we're going to do the four-step process that we talked about earlier. State, plan, do, conclude. We're going to go through that for multiple problems. Recall that we need to be dealing with categorical data when we're talking about confidence interval estimates. So we have to determine first whether we're dealing with categorical versus quantitative in order to be able to use proportions. If it's quantitative, you want to use means. So a poll of students asks each student to give an estimate, the number of casualties. So the number of casualties, that's a number, would be an average. That is quantitative. A poll of students shows that 2 out of 3 do not support. So the question would be, do they support or not? That's a yes/no answer, so that is categorical. A local newspaper claims that 67% of the residents support a bond measure, and then we got 85 out of 100. So do they support it or do they not support it? That's a yes/no as well, which is categorical. Now, a local newspaper claims that the county residents commute on average 18 miles. That's numerical, which is quantitative. Okay. Which of the following research questions involves testing a claim about a single population proportion? According to the National Post-Secondary conducted, the average student loan debt, well, that's quantitative, that's mu. So this is not proportion, which means that this is not about a single population proportion. What proportion of students at the college commute more than 5 miles? Well, they're asking us, what is P? That's a confidence interval. We're trying to capture P. That's not testing a claim. According to the College Board, 62% of students graduating from the college with an associate's degree had no student debt. Has this figure increased? So we're talking about P equals 0.62 and P greater than 0.62. It's a proportion, and we're talking about a single community college as a whole. We're talking about community colleges, not like male students and female students. So this is talking about a single proportion. And then in the end, the last question, there's proportion of males and females. So that's two populations. So we'd have P1 and we'd have P2. So that is not going to work for us. All right. According to the American Association of Community Colleges, 23% received federal grants. The California Community College Chancellor's Office anticipates the percentage is smaller for California community college students. They collect a sample of 1,000 community college students in California and find that 210 receive federal grants. For which group are we making a hypothesis? Who is our group that we're performing inference for? California community college students. So this is the population of community college students in California. A sample is not what we're making inference about. The null and the alternative, since we're talking about proportions, we're going to say P is equal to, and P is less than because we're asking about smaller and we're using 0.23. And the P is what? What is the population that we're talking about? It's the proportion of, not 1,000, that's sample. It's a proportion of California, yes, not just regular community college students who receive federal grants. This is the number of recipients, that's different. That's not the proportion. Okay, we're going to rely on StatCrunch for these calculations rather than the applets and OLI. Now, we are going to conduct our first full hypothesis testing, which means that we're going to state, plan, do, and conclude, and we'll go to StatCrunch to get some calculations as well. So we're going to state, which in our state, the first thing that we do is we write our hypotheses. So according to the CDC, 60% of all Americans ages 18 to 24 currently drink alcohol. Is the proportion of community college students who currently drink alcohol different from the proportion nationwide? A survey of 450 community college students indicates that 66% currently drink alcohol. So our null is that the proportion is equal to 60%, and our hypothesis is that the proportion is different than 0.6. Okay? Now, we've stated our hypotheses, but we also need to identify the parameter that we're talking about. So what does P represent? What's the population we're talking about? So we say where P is the true population proportion of California community college students who drink. And we want to use an alpha equals 0.05 level of significance. That's not given, but that's our standard if we don't have a given level of significance. In our plan, we want to check conditions. We want to check random and we want to check normal, and I think you should check independent, but the book doesn't talk about this. And independent is checked by calculating whether your sample size is less than 10% of your population. Now, we had a random sample, yes, random, as stated. And then we have to check our normal conditions by doing NP greater than or equal to 10 and N1 minus P greater than or equal to 10. Well, N was 450 and our population proportion was 0.6. So we have 450 times 0.6 and 450 times 1 minus 0.6, which gives us 270 and 180, which are both greater than or equal to 10. So normal is met and random is met. In the do, we want to calculate the test statistic. Well, what does that mean? We have p hat, which is equal to 66%, so 0.66. Our p was equal to 0.6. And now we need to calculate the test statistic. That's the z-score. And remember, the z-score is found by doing p hat minus p divided by p1 minus p over n. That's the same thing as 0.66 minus 0.6 divided by 0.6 times 1 minus 0.6 over 450. If you run that number, if you do those calculations, you should get 2.598. Now you'll notice in the text in OLI, it talks about one-tailed versus two-tailed testing. A two-tailed test means that we're talking about a not equal to, and a one-tailed is when we're talking about problems for greater than or less than. This is a two-tailed test, and we're going to rely on StatCrunch to tell us what the p-value is. I'll walk you through those calculations now.